We need to determine the sum to n terms of the following series. Let us begin. So here we have a series with first term being 1, followed by 4, then we have 13, next we have 40, followed by 121, and the rest of the terms. Now this particular series is not an arithmetic series, for it does not have any common difference, nor it's a geometric series because we cannot find any common ratios here, but there is a pattern here. So if we take the second term and from it subtract the first term, that's going to give us 3. Taking the third term and subtracting the second term from it gives us 9. Next, take the fourth term, subtract the third term from it, that's going to give us 27. And if we take the fifth term and subtract the fourth term, 40, from it, that's going to give us 81. Now clearly 3, 9, 27, 81, these terms are going to be in geometric progression. They're going to be in geometric progression with first term equals to 3 and common ratio r equals to 3. So what we will do, we'll use the method of difference to obtain the sum up to n terms. For this, let us suppose that Sn denote the sum to n terms of the given series. So here we will consider the last term of the series and denote it at Tn. Then we can also express the second last term as Tn minus 1 to take the same sum. So now what we'll do, we'll take the first term 1 and write it below 4. For the next term we will consider 4 and we're going to write it below 13. Then we have 13, we're going to write it below 40, and the term 40 will be written below 121. So this is going to continue. Then we have Tn minus 1 added to Tn. Right. Now what we'll do, we're going to subtract both of the two series. Now on the left hand side, we have Sn minus Sn, so that will give us 0. We have the first term that stays as 1. Next, what we have is 4 minus 1, that's going to be 3. Added to 13 minus 4, so that's 9. Added to 40 minus 13, so that's 27. Added to 121 minus 40, so that's 81. This is going to continue, and then we have Tn minus 1 minus Tn minus Tn. Fine. Now what we'll do, we'll take this Tn to the left hand side. So Tn, that will be equals to 1 added to 3 added to 9 plus 27 plus 81, and we have all the way up to the last term, which will be Tn minus 1 minus Tn. Now as we can observe, the terms on the right hand side are forming a geometric progression. So that means what we can do, we can find out the sum, and since it's a geometric series, we can find out the sum. So here the sum, which is given by the formula, the first term a multiplied to r raised to the power of n minus 1 divided by r minus 1, with the absolute value of r being greater than 1. So here what we have the first term, that's 1, that will be multiplied to the common ratio r, which is 3, raised to the power of n. So there are a total of n number of terms, minus 1 whole divided by 3 minus 1. So that means we have half multiplied to 3 raised to the power of n minus half. This is going to be the nth term of the series. So now that we have found out the nth term of the series, we can easily find out its sum, because we know that the sum to n terms was simply defined as take the summation of the nth term but replace the index n with k. K runs from 1 to n, which means that we have to find out the summation of half multiplied to 3 raised to the power of k minus 1 half. And here we have the index k running from 1 to n. Now we will find out the value of this summation. So we will have 1 half multiplied to summation of 3 raised to the power of k. So here k runs from 1 to n, minus 1 half times the summation of 1 with k running from 1 to n. This is going to be equals to half times. Now what is summation of 3 raised to the power of k? So to find out the first term, what we'll do, we'll replace k with 1. So that gives us 3 raised to the power of 1, or simply 3. Then the next term, that's going to be 3 squared added to 3 cube, and this goes all the way up to the last term, that's given by 3 raised to the power of n. minus 1 half multiplied to, now we have summation of 1 with k running from 1 to n. This simply means that we are adding 1 to itself, and this is going all the way up to n number of terms, or in case n number of terms 1 is getting multiplied to itself. This is going to be equals to half multiplied to, now this is again a geometric series with n number of terms, first term being 3 and common ratio being 3. So we have 3 multiplied to 3 raised to the power of n minus 1 divided by 3 minus 1, so that's 2, minus half multiplied to 1 times n, so that's simply going to be n. Now what we'll do, we are going to simplify this, and that finally gives us 3 over 4 multiplied to 3 raised to the power of n minus 1 minus n over 2. Okay, so let's multiply this 3 with the two terms inside the parentheses. So we have 1 quarters mul of 3 raised to the power of n plus 1 minus 3 minus n over 2. So this is going to be the final sum to n terms of our series, which is given by, we have 1 plus 4 plus 13 plus 40 plus 121.